Math students, this is our introduction video for our lesson on exponent rules. In this lesson, we're going to talk about different rules you can use when you're doing math with expressions that have exponents. So first is going to be all about multiplying with exponents, and I'm going to use the example here, x cubed times x to the fourth power, to help explain the rule. When we learned about exponents, we said it means that's how many times you're multiplying the base. So for example, x cubed means we're multiplying x times x times x. And x to the fourth power means we're multiplying that by x times x times x times x. So when we look at it all together, I've got x times x times x times x times x times x times x. That is just the same thing as x to the seventh power because I'm multiplying x by itself 7 times. Now, we could every single time write out x, 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 or we can notice what we're doing with those exponents. I have a 3 and a 4, and my final answer is a 7. It means in multiplication problems, we just need to add the exponents. So for example, in this next problem, 6b to the 8th power times 3b squared. The numbers, it's a multiplication problem, so we still multiply those. I still say 6 times 3, that's 18. But when it comes to our variable, what should my exponent be? I have an 8 and a 2. This is a multiplication problem, so we said we add the exponents. Hopefully you're saying the number 10. So that's our first rule. Our second rule is what you do when you are dividing with exponents. So similarly, y to the 5th power would mean y times y times y times y times y, and y squared means y times y. Well, when you're dividing, anytime you divide something by itself, it cancels out. So we see this a lot when we solve equations, for example. We say those 4's cancel out, and it just leaves me with x. Over here, that means I can say these y's cancel out, these y's cancel out, and I am just left with 1, 2, 3 y's. Now again, you could write these out every single time, or you can just notice we had a 5 and a 2, and now we have a 3. What did we do with those exponents? We subtract. We subtract because you're canceling out the ones you have, you're removing those and seeing what you're left with. So for this last one here, 10z to the 10th power divided by 2z squared. The 10 and the 2, this is still a division problem, so I can divide those. 10 divided by 2, that's 5. But then when it comes to my variable, my z, what exponent do we need? We have a 10 and a 2. We said we need to subtract, so our exponent is 8. Our third exponent rule is when you're raising an exponent to a power. So an example of what I mean by that is this problem here, where you have something with an exponent raised to another exponent. To help explain what we need to do here, I'm going to start with 4 squared. We have learned that 4 squared means 4 times 4, and so then, you could do the math. That means something similar here too. 4a cubed, all of that squared, means we are multiplying this by itself, the same way we multiplied 4 by itself. So 4a cubed squared means we're doing 4a cubed multiplied by 4a cubed. Now if I write it out like that, it helps me see what I need to do. I still need to do 4 squared. And so I'm going to break this up into 2 colors. I still need to do 4 squared because 4 squared means 4 times 4. And 4 times 4 is 16. But for my exponent, because I'm squaring it, it means I have a cubed times a cubed. That's what we learned up here. In multiplication problems, you add the exponents. A cubed times a cubed is a to the 6th power. But if I didn't want to have to write this down, or if I gave you something like a cubed to the 10th power, look at what we're doing with those exponents. The original problem had a 3 and a 2, and my final answer was a 6. That means when you raise a power to a power, 3 to the second power, or 3 squared, we have to multiply the exponents. So for example, over here, I do not want to have to write a cubed times a cubed times a cubed times a cubed 10 times. I can just say I need to multiply my exponents and say 3 times 10 is 30. One final problem, and then you are ready for the lesson. The last problem is about the zero exponent. So for example, 8 divided by 8, hopefully we know that is 1. But for this problem here with exponents, if I use our division rule, which says subtract exponents, if I subtract 5 minus 5, that gives me 0. Now c to the 5th power divided by c to the 5th power equals c to the 0 power. That is true, but this is not simplified. There is more we can do. The rule we have for the 0 exponent is anything to the 0 exponent equals 1. The same way 8 divided by 8 equals 1, if you're dividing something by itself, it equals 1. That means if you ever see a variable to the 0 exponent, it means there are 0 c's, and so all I have is the 1 that's in front. C squared means c times c. C means c, but c to the 0 power means there's no c's, just that number 1, that coefficient in front. In today's lesson, we're going to be looking at a lot of practice problems that use these 4 rules to help us make sure we know them for our future lessons on multiplying and dividing polynomials. Thanks so much for watching. You are ready for today's lesson.